So I'm going to start talking quite broadly about human origins and expansions to suggest that the western margin of the Asian monsoon system marks a key ecological threshold for examining human dispersals. For the next part of the talk, I'm going to focus in a bit more detail about my work in the Thar Desert in Rajasthan and Gujarat in Western India, and then try and put that in a bit of a broader regional context. And then to finish up, I'm going to look in a bit more detail about this idea about transitions, and particularly looking at the late Acheulean to Middle Paleolithic transition. So Homo sapiens appear in Africa around 300,000 years ago, broadly contemporary with the appearance of the Middle Stone Age, where we see replacement of assemblages dominated by large cutting tools, with those focused on flake-based tools, the use of Labawa technology, alongside long-distance transport of materials and the use of ochre. And it's increasingly apparent that Homo sapiens is unlikely to stem from a single region in Africa, and rather that there is a mosaic appearance pointing to substructured populations with varying patterns of connectivity through time. And our recent paper on Mtoto, Africa's oldest burial from Pangasivi in Kenya, shows this really nicely. Even in Eastern Africa, we see really significant diversity in human morphology until quite recently. So while our perspectives on the origins of Homo sapiens within Africa are changing, we do remain clearly an African population. Now, in the time frame I'm looking at here, it's just one of many hominin populations. With the exception of Homo naledi, the rest were all Eurasian populations. Now, these include Neanderthals, which are perhaps best known, more scant evidence for Homo floresiensis, luzonensis, as well as the youngest populations of Homo erectus in Southeast Asia. And while fossils of Denisovans are coming to light, they remain better understood from genetic records. What isn't talked about as much is the late Middle Pleistocene hominin from India, represented by a single specimen from the site of Hathnora in the Narmada Valley. And this is partly because it is the single pre-sapiens fossil we have from the region, and partly because of the mosaic of features that it preserves, so that Sheila Threya, who has undertaken the most detailed comparative studies of the specimen, characterizes it simply as a mid-Pleistocene Homo, emphasizing that it has traits comparable with contemporaneous Eastern and Western Eurasian hominins. So this adds to a picture that not that long ago, Eurasia bustled with very diverse hominin populations, but today it's only ourselves, Homo sapiens, that remain. So what's changed? But as we know, at some point, modern humans have expanded across the world and replaced all our closest relatives. These two maps provide two quick snapshots of the alternative approaches to the timing of this. Now, the widespread distribution of Homo sapiens across Eurasia and Sahel by 45,000 years ago is uncontroversial and illustrated on the right. Now, the presence of Homo sapiens burials in the cave sites of Sri Lanka fits right at the start of this phase, whereas in mainland South Asia, fossil evidence for Homo sapiens is restricted until after the last glacial maximum, so after 20,000 years ago. And this is a major confound to studying human dispersals in the region. A broad range of genetic studies suggests ancestry of populations alive today can be traced back to population expansions around 60,000 years ago. That's a key line of support for some younger dispersal models. Looking at earlier dispersal models, the oldest archaeological evidence that we see from Australia at Majubavi dates around 65,000 years ago in Southeast Asia. Homo sapiens appear by around 70,000 years ago at Tampaling, and at multiple sites in China, it suggests their arrival by around 100,000 years ago. So these support an earlier time frame for this expansion. The presence of Homo sapiens in Western Asia in MIS5, both from Arabia and the Levant, is well established and supports expansion at this time. But recent evidence from Mislia and academia potentially indicate that they also represent part of a longer pattern of occupation of the Eastern Mediterranean or Southwest Asia, stretching into the Middle Pleistocene. I think within this, we can also acknowledge that there's potential for significant human expansions to have occurred within Africa as well. It's not something that we should treat as a monolithic entity. So moving to look at why I focus some of my work in the Thar Desert, it's partly a region in which I identify some key thresholds and key thresholds for examining human dispersals. One of the key influences that we're looking at here really is the impact of the monsoon and its seasonality on ecology. And this is what results in monsoonal Asia forming one of the world's major biogeographic zones, here identified by Holt as the Oriental Zone on the right-hand side. Now, this leads me to take something of a biogeographic approach to examining human dispersals, where rather than looking at the narrow geographic point of contact between Africa and Eurasia, I'm looking at where we're seeing some of the most substantive ecological changes as key points for where we'd need to see, or would likely see, adaptation amongst Pleistocene human populations. So some of these changes aren't necessarily just ecological. We see a big change in topography, moving from high altitude and high relief landscapes such as the Iranian Plateau, as human populations moved eastwards. As they cross these mountain chains that surround South Asia, that have moved into typically low altitude hills and broad valleys of the Indian subcontinent. Associated with this change is a change in geology between the Indian and Eurasian tectonic plates, modulating the nature, distribution, and package size of alternate raw material resources for stone tool production. So this would be a really discrete material change that's readily evident in the hands of Pleistocene populations. So crossing this boundary would have presented adaptive challenges, but at the same time, persistent humidity provided by the monsoon removes the threat of extinction from aridity that is present across the desert belt to the west. Now, taking a step inwards in this region, here I've just shown a number of records of monsoonal intensity, with the Bitu Cave record shown in green, marine records from the Bay of Bengal and Arabian Sea in red, as well as the Vostok and Uzbek records in blue. Now, the monsoon is such a defining climatic feature of the Oriental Zone, which is influenced by both northern and southern hemisphere patterns of glaciation. Glacial maxima broadly match with weak monsoons, and strong monsoons are evident in interglacial phases. So, as you can see, here's the last glacial maximum, and as you can see in almost every record, this is pulled out as a period of low monsoonal intensity. And at the peak of the last interglacial phase in MIS5e, again, we can see some evidence for prominent monsoonal activity. But orbital features such as precession have significant impacts on insolation and thus the monsoon system. And this is evident in equally strong monsoons shown in glacial and in interglacial phases. And we can see examples of this, such as in the records in at the end of MIS6, or perhaps more prominent in MIS3, and at the start of MIS3, where some records, particularly the Arabian Sea records, show monsoonal intensity matching or perhaps exceeding that of the last interglacial. The flux in monsoon and precipitation is likely to be one of the most tangible ways in which these broad-scale climate changes would be felt on the ground, both across South Asia and in the Thar Desert as a key place for examining human dispersals. Now, the alternate activation of aeolian or fluvial activity within the region appears closely tied to these records of monsoonal flux. Now, the Indus River stands as the only fluvial system that rises in the mountains to the north, crosses the region today, but it's clear in the past there have been other channels running broadly parallel across the Thar Desert. Now, while much of this debate surrounds the Gagra Hakra River, shown on the left in purple, and relates to its potential role in the rise and fall of the Indus civilization. Dating of Gagrahaka channel deposits shows that it was an active fluvial system between MIS 4 and 2, so between around 65,000 years ago, right up to the start of the Holocene, taking water from the Sutlej drainage across the central desert region. Now, on the right, I'm extrapolating from some remote sensing work that's investigated earlier channels across the Thar Desert and broadly matches with research I've taken with Hemrat Juthan and Nala Quarry. That suggests a comparable river channel took water from the Himalaya across the Thar Desert prior to migrating to the better known Gagrahaka course. So I've begun to question the extent to which this fluvial landscape provided a vital buffer for eastward expanding populations. The continuous accessibility of water that may have provided a lifeline at the eastern margin of the desert belt, providing security against the risks of aridity. Now, this stability would have provided expanding populations the basis to engage with new resource bases, new patterns of seasonality, and new patterns of mobility, and successfully adapt to the monsoonal landscapes beyond. So moving on to talk about the Paleolithic archaeology of the region. Like much of South Asia, there's a very long history of Paleolithic research here, stretching back into the 19th century. And a vast number of sites have been identified, but the majority of them comprise undated surface sites. When I started working in the region a bit over a decade ago, Sixteenhour June yielded the only dated and excavated Paleolithic assemblage, leaving a lot of the rest of this data easy to overlook. But I felt uncomfortable dismissing this wider body of evidence out of hand. So in a recent paper, I presented a cluster analysis of stone tool assemblages from the literature spanning 94 Acheulean, 123 Middle Paleolithic, and 142 Late Paleolithic sites to see what I can make of this data, building on some of the work I've been doing in Eastern Africa with Matt Grove. Some of the results are fairly straightforward. Assemblages reported as Acheulean frequently include hand axes and cleavers. Levallois technology is most frequently reported in Middle Paleolithic assemblages, with blades and back pieces prominent in Late Paleolithic assemblages. But what is interesting is that there were few exclusive relationships, with only basally modified pieces and borers absent from the Late Acheulean, and large cutting tools absent from the Late Paleolithic. So there are potentially some interesting overlaps here. So looking at constellations of artifacts that are found together, shown on the dendrogram on the left, we can see at the bottom in green a fairly classic package of Acheulean artifact types forming a discrete group. So cleavers, hand axes, choppers, and knives. Blades, back pieces, and burins all feature prominently in Late Paleolithic assemblage, also grouped closely together, but not discrete in the same way, and they cluster with artifact types that are also prominent in Middle Paleolithic records. Now, looking at the relationship between the assemblages and comparing them, their attribution to cultural groups, shown in the dendrogram on the right, we see a comparable pattern. Acheulean assemblages, this time shown in blue, typically appear discrete from other phases, so that cluster right at the top. We see one cluster of Late Paleolithic assemblages in red that are similarly discrete from Middle Paleolithic assemblages, so the next branch down. But we also see clusters of Late Paleolithic assemblages and Middle Paleolithic assemblages overlapping with one another, suggesting that they share more in common with one another than they either of them do with this discrete Late Paleolithic group. Now, this pattern fits with suggestions of a gradual transition from Middle to Late Paleolithic technologies, and it might help us identify those assemblages and artifact types of interest to examine this transition more closely in the region. And so from this example, focus on productions of blades, retouch points, and back pieces can be identified as of interest. So I'm going to look at some of the dated and excavated sites in more detail, and I'll start with Sinki Tala. Now, this site was excavated in the 1980s by a team led by Vien Misra, who opened up 72 square meters of fine-grained lake deposits, revealing archaeological horizons mostly in the top 1 meter of these lacustrine deposits. Now, the site has been linked to a dated carbonate sample from 2 kilometers away, and which dates to 797,000 years ago. But I think there are some problems both with the link between these two sites and the date itself. And even when this date was reported, experimental issues with the sample were identified. There's no clear connection between this site and the excavated assemblages, so perhaps this link is inappropriate. Now, the site is described as having 3 in situ Acheulean occupations in layers 3, 4, and 5, as well as having Middle Paleolithic and Mesolithic artifacts in the upper layers. Most focus on the archaeology at the site is on the large cutting tools, supporting the Acheulean attributions of the larger assemblages, and comparative studies by Kerry Shipton have suggested comparability with other older Acheulean sites in India. Now, while the core technology is not clearly described from the site, the illustrations I'm showing on the right suggest the potential presence of hierarchical bifacial cores. I think reanalysis of this assemblage could help illuminate broader patterns of behavioural diversity at the site than are currently apparent. One unique feature of this site is the recovery of a small collection of monopyramidal quartz crystals shown in the middle, associated with one of the stone tool assemblages, and are considered to be manuports. So this gives us a very slight and obscure insight to Acheulean life beyond stone tools. Moving about 5 kilometers away in the Balia Hills, we have the site of Sixteenhour June, another site excavated by V. Misra, and the first reported from India with lower, middle, and upper Paleolithic horizons, as well as a Mesolithic horizon. And critically, this excavation was integrated with the use of chronometric dating. So this is really a key achievement here. As you can see from the photo, this is a really significant undertaking. The first trench reached about 90 meters in depth, with 30 square meters opened up, recovering what was first identified as an upper Paleolithic assemblage based on the age returned from a radiocarbon date on a carbonate sample. Now, unfortunately, on re-examination, the sequence isn't as clear-cut. Firstly, Claire Gaillard undertook detailed study of the lithic assemblage, with the main artifact concentration best described as a middle rather than upper Paleolithic assemblage. And this is more consistent with the results of recent dating, which constrain it between ages of 40 and 80,000 years ago. Now, the lower levels document activity at the site at an earlier time, dating back to the start of MIS 6. So the time frame that we're seeing a river flowing at Nile, so right in the middle of the desert near Bikaner. But the assemblages are sparse and lack diagnostic elements to resolve confidently between a middle or a lower Paleolithic attribution. Now, staying in broadly the same vicinity, about 50 kilometers down the road is the site of Kototi. And shown on the left is the landscape. It's a photo I took almost exactly a decade ago with my collaborator, Hema Atchuthan, while I was doing my DPhil. Now, over a couple of papers, we have documented the sedimentary sequence from the site, split between the lower fluvial deposits, which comprise the margins of a braided stream system, and the upper podogenized sand dune deposits. Isotopic studies have revealed a substantial shift in flora between these two phases, with higher proportions of seafall vegetation associated with the lower fluvial phases, suggesting stronger summer monsoons. We recovered 3 intact assemblages from layers S8, S6, and S4, with potentially reworked material in layers S5 and S3. We used luminescence dating and AMSC14 dating to constrain the main archaeological horizons between 96,000 years ago and 60,000 years ago. At the time of publication, these were the oldest Middle Paleolithic assemblages in India. These artifact assemblages fit well with regional descriptions of Middle Paleolithic, including the presence of alternate lava reduction strategies alongside other forms of prepared core technologies, and a range of both simple and more formal retouch tools, most notably the presence of tanged and shouldered points. And we were recently able to conduct a field season in late 2019, and this is supported by funding from the Leakey Foundation. But as you can imagine, much of the post-fieldwork processing has been caught up with COVID-related disruption. So it's still a little too early to really talk about some of the analytical outcomes of this work. Moving to the center of the Thar Desert region, I've conducted some survey work to try and bridge the gap between these northeastern sites. So I've just been talking about the sites in this region here, and some of the sites known from further south. So I was working in the landscapes at Chamu, at Shergar Tri Junction, and in Kana, all in the Luni Valley. I was able to capitalize on existing geochronological frameworks from paleoenvironmental studies at these sites. Now, this enabled me to explore sediment formations dated between MIS6 and MIS2 with the aim of identifying artifact assemblages that could be directly associated with these dated sediments. Across these three sites, I was able to identify Middle Paleolithic artifacts from sediment units dating between 80,000 years ago to less than 43,000 years ago. Two of the key points to highlight from this work were the presence of alternate approaches to point production, both façonnage, so shaping through retouch, and debitage, the shaping of the core to produce blanks of particular shapes, as well as alternate approaches to blade reduction amongst the youngest assemblages where Levawa and non-Levawa methods were found to occur side by side. Now, moving further south and down towards the Gujarati coast, where I've been working with a team from MSU Baroda in collaboration with Professor Ajit Prasad. The region you can see in the larger map here is Kutch, and I've seen a single Paleolithic survey about 50,000 years ago, about 50 years ago, that highlighted the potential of this landscape for more work. Now, another key factor attracting us to work here is the proximity of the coast, given the significance of coastal routes in a range of alternate dispersal models. Now, while sea level changes could have modulated the proximity of the coastline, the deposition of 100 meters of sediments in the Indus marine fan throughout the Holocene, as well as active tectonic uplift, suggests this is likely to be much more limited than evaluation of modern bathymetry would suggest. So we undertook survey work in a large number of Kutch's drainage basins, finding widespread evidence for Middle Paleolithic occupations associated with late Pleistocene sediments. In contrast, microlithic technologies, a key component of late Paleolithic industries, were entirely absent from late Pleistocene contexts and were only found on top of Holocene deposits. So this failed to support key hypotheses proposed in coastal dispersal models. Now, we've been conducting more intensive investigation of one of these sites that we have identified at Sandab in the Naira Basin. In the photo on the left, you can see our first section of the site, Avi Mukuji, in the midst of sampling, where we expose the uppermost of 4 major sediments units at the site shown schematically in the middle, with that white carbonate-rich deposit marking the top of the second unit. Stable isotope work by Patrick Roberts has helped us to resolve elements of the ecological sequence, indicating that the main artifact horizon we've recorded to date was characterized by high proportions of seafloor plants, again likely correlating with enhanced summer monsoons. And working with Julie Durkin, we've dated this horizon to around 114,000 years ago. Amongst the artifacts recovered, one stands out in particular, shown in the top right, this example of a tang point made on beautifully green silicious material. So we've been back again to work more in this landscape and hope to be able to expand both the artifact collections from this site, as well as further constrain the chronology and examine geomorphology or geomorphological evolution in the landscape in the future. Finally, one of the key late Paleolithic sites in the region, first identified by Bridget Olchiner and her team in the 1970s, is Buddha Pushkar. The photo on the top left shows the location of the site in the Pushkar Valley at a key pass in the Ara Valley range. The artifact assemblages were recovered from freshly eroding dune horizons, allowing them to be readily tied into a stratigraphic framework. But these deposits were not dated until the 90s and were never integrated, and these two lines of evidence were never really integrated. So a couple of years ago, I did a new study of lithic technology, combining this with published stratigraphy and published dates to allow us to better fit the site into current debates. So there were two groups of assemblages, broadly split between the older group dating to 27 to 22,000 years ago, and a younger group dating between 16 and 13,000 years ago. Some elements of the technology are precisely what you might expect. Assemblages with a predominant focus on blade or bladelet production, with the inclusion of burins and some back pieces. But what was really notable, and particularly in the older group, is the continued use of other flake reduction strategies, producing broad blanks, including the presence of Lavallois technology. So as a quick summary from Western India, we don't really yet have good chronological control on the Acheulean in the region. The available dates are either minimum ages or unreliable. And though typified by the presence of bifaces and cleavers, the potential presence of hierarchical bifacial core technologies at Singitala, and engagement with non-functional material culture of these crystals suggests there's perhaps greater complexity yet to be revealed here. The Middle Paleolithic appears from around 114,000 years ago and dates to less than 43. And this includes classic features such as Lavallois technology, alternate methods of point production, as well as the rare presence of bifacial tools, often at a much smaller scale than for Acheulean pieces. And so I've just shown in the center an example of this really finely crafted miniature biface, really, from Sanda. Now, our surveys have failed to support models predicting the early appearance of late Paleolithic technology along the coastline in India, with the occupations of Buddha Pushkar dating from 28,000 years ago, showing the combination of a focus on small blade technologies, but with a persistence of some of those key technological features of the preceding Middle Paleolithic. So I'm going to start trying to fit this into a broader regional framework for you, working around some of the key records from other regions in South Asia. So we can start off looking at Eastern India. And I'm starting here because partly the records are very new, but also they're very sparse, with only late Paleolithic assemblages really clearly identified in the region and placed into any chronological framework. Here, we see late Paleolithic technologies appearing from 42,000 years ago onwards, including different reduction approaches for blade production and the production of broad flakes from prepared cores. Looking to north-central India and the Middle Son Valley sites in particular, we see good chronological control on the late Acheulean, and it's particularly notable as the youngest Acheulean occupation in the world, appearing with a classic combination of hand axes and cleavers alongside discoidal cores and some simple flake tools. But what is interesting here is the presence of invasive flaking onto individual biface surfaces, producing a hierarchy of surfaces for flake removal before discard. And that's shown in the illustrated in that scan in the top center. Now, these later Acheulean records stand in stark contrast to the use of recurrent Lavallois reduction that characterized the Middle Paleolithic occupations that here date between 80 and 47,000 years ago, notably spanning the eruption of Toba, and we see no change of technology really on either side of this on this event. And comparative work regionally has shown clear parallels with the technology we see in the Middle Paleolithic technology from the Middle Son Valley, with technologies associated with Homo sapiens in Southwest Asia and in Africa. With the late Paleolithic appearing from 48,000 years ago, there's a change in focus from centripetal to uni or bidirectional flaking practices, including a greater focus on blade reduction, the use of backing, as well as the presence of ochre, with a notable absence of Lavallois technology. Turning to central India, at its lower age range, we only have minimum ages for the later Acheulean, perhaps older than 106,000 years ago, with older sites dating clearly into the Middle Pleistocene. Now, one study I do want to highlight here was by Kerry Shipton, showing that cleavers from Bimbeca were made on end-struck flake planks rather than side-struck flakes of cobbles. And this likely required considerable control of flaking convexities to achieve. Similarly, the chronology of the Middle Paleolithic isn't well constrained here, with some minimum ages from Bimbeca and isolated artifacts from Metikeri dating to around 65,000 years ago. So here I just actually illustrated some of the presumably younger Middle Paleolithic from Patney. The late Paleolithic appears in the region from around 44,000 years ago and combines a focus on blade production with continued broad flake production from prepared cores. At Patney, small blades are apparent in the Middle Paleolithic, and this is shown in the graph in the bottom right, with the Middle Paleolithic being period 1. We then see a gradual decline in the size of blades in the earlier late Paleolithic assemblages, with some similar gradual changes observed in frequencies in other artifact types. So this I see as another good example of there being a gradual change from middle to late Paleolithic technologies. Moving southwards and looking at the Goa Valley, we have limited detail on the Acheulean, an age estimate from the terminal Middle Pleistocene that is comparable to that seen in the Middle Sun Valley. The Middle Paleolithic here is famous for showing little change across the eruption of Toba, 74,000 years ago, with this continued focus on centripetal reduction schemes, and again comparable to those used by Homo sapiens in Southwest Asia and Africa. But it's also notable for having the youngest Middle Paleolithic in the region, dating to 34,000 years ago. Now, key features of the late Paleolithic start appearing from 35,000 years ago, and are foreshadowed in these young Middle Paleolithic horizons. Differences in raw material use, artifact sizes, and flaking directionality, which are then elaborated upon further with greater focus on blade production and the use of backing into the late Paleolithic. So we're going to jump to Sri Lanka, where to date there's no confirmed Acheulean presence to my knowledge. Evidence for the Middle Paleolithic is currently very sparse, and hopefully it's something that should be changing in the near future. But a single site at Bundala on the southern coast currently ties a Middle Paleolithic occupation to 80,000 years ago. And I thank Oshan Wedigay for actually being able to show me some of the artifacts from this site. However, we have a much richer record for the late Paleolithic, where lithic technology is heavily focused on bipolar reduction strategies to the near exclusion of blade-based elements. We see a very rare production of retouched stone tools, but these assemblages are complemented by a much clearer use of organic technologies for tool production, starting from 48,000 years ago, shown by these bone points on the right-hand side. Now, finally, jumping back to southern India, we have Attarampakam. I've left this to last as it breaks the pattern we've seen elsewhere. So the Acheulean occupation of the site, of course, is very old, the oldest dated in South Asia. But what I really wanted to focus on a little more is the Middle Paleolithic again. Also reported as the oldest in South Asia, and would also be the oldest Middle Paleolithic reported across the world, dating at 385,000 years ago. Now, these assemblages are reported with Lavawa technology and point production, and the rare presence of bifacial tools, including some examples of preferential removals from hand axes. Looking from the top down, we can see some broad continuities across much of South Asia, with Acheulean industries persisting up until the end of the Middle Pleistocene, maintaining a focus on the production of large bifacial tools, the absence of true Labawa technology, but perhaps some hints of changing approaches to flaking practices. Middle Paleolithic technologies first appear in most regions in MIS5 and persist into MIS3, sharing the use of Lavawa, discoidal, and some blade and bipolar reduction methods, with alternate approaches to point production, as well as some limited continued presence of diminutive bifaces. The earliest late Paleolithic technologies appear from the second half of MIS3, from around 48,000 years ago onwards. They share a focus on the use of finer grained raw material types and the production of smaller stone tools, but with a varying and regional focus in the use of bipolar, blade, or flake reduction methods, with the Middle Son and Jurero valleys showing good examples of gradual changes from preceding Middle Paleolithic industries. Now, the Middle to Late Paleolithic transition in South Asia has drawn considerable debate, but I think the reports from Atarampakand present an important opportunity to draw focus on the later Schuling to Middle Paleolithic transition. So I'm going to move on now to talk about how we might look ahead and think of tackling this transition in the future. Now, I want to start with a quick word of caution in terms of some of the terminology that we use, as terminology always comes with theoretical biases, and we need to be explicit about them. So while this study by Tash Reynolds and Felix Reeder is focused on Europe, it's a great example here showing how tangled taxonomies can cause some very real problems for archaeologists. And these issues come to the fore when we look at transitions, and we need a really clear idea of what is being transitioned to and from. Now, in the literature, we see that there is a trend to identify industries as transitional as something of a shorthand. Often when you find mixed assemblages and you're not sure where it fits with one or the other. When looking at these changes, however, I think it's necessary to drop down some of the steps shown on this pyramid on the left or this house of cards, rather than using the cultural taxonomy, so these names for industries, thinking about constellations of artifacts that constitute the assemblages that we're looking at, and going back even to the context that they were recovered from in the field. Now, as well as theoretical, there are some practical reasons to be very careful about classifying and naming transitional industries. We know that the archaeological record is the result of complex cultural and physical processes, and they're also influenced by the methods that we employ in the field too. So working with samples from controlled excavations of fine sediments is rather different from recovering samples from gravel horizons just from a pedestrian or surface survey. So in this neat study by Coco and colleagues, they look at this question of transitional industries using an agent-based modeling framework, highlighting that if you have two chronologically structured industries, so one discrete industry preceding another, so you can imagine that being the Acheulean preceding the Middle Paleolithic, there is a high potential for transitional industries to become apparent in the archaeological record through recycling behavior, the latter population reusing elements first worked by an older population. And just to illustrate this issue, I put up an example of a double patinated biface we recently identified at Kototi. So you can see that the trimming around the edge shows a different patination from some of the original flake surface seen in the center. So I thought it might be useful to simply sketch out schematically what sorts of changes going on in stone tool assemblages that could characterize a major cultural change. As a simple example, we can look at the occurrence of alternate tool types labeled simply 1 and 2, and we could easily pick, for example, bifacial tools and Lavawa for the Acheulean Middle Paleolithic transition, or perhaps patterns of directionality of core flaking for the Middle to Late Paleolithic transition. So in the most extreme cases, there'd be no overlaps in the presence of these types, and so a major cultural change is very clear-cut. But we can also imagine other examples of overlaps in either the presence and absence or proportional appearance of either type, making such changes less obvious. So where in all this do we decide that there has been a clear transition from the type 1 to type 2? Looking through the literature, the appearance of a new technological feature is always emphasized over continuity or loss of an existing feature to characterize change. So that's the point of that we'd see in innovation. And it partly supports what we see from the point from the last slide, that continuity could always be partly tied up with these issues of recycling tools, extending their appearance in the archaeological record. But there is also broader debate about whether the first appearance of a new technology or when it becomes the dominant technology may mark the key threshold to identify cultural change. But perhaps there's no easy answer to that. Just to put this back into a bit of archaeological focus, this is a rather caricatured approach, and I think it's worth remembering just how messy archaeological data can be. And this grid on the right-hand side shows the presence and absence of alternate tool types from left to right in Middle Stone Age stone tool assemblages from Eastern Africa, shown from top to bottom. What I'm really just trying to exemplify here is quite how messy and sporadic stone tool assemblages can be. And sometimes, rather than looking at individual types, we need to look at the constellations in which they occur, perhaps as better ways to look at patterns of cultural change. Now, the nature of transitions between major cultural phases is undoubtedly complex, but to my mind, there are some three very basic alternatives. Firstly, we could see cultural change coming as a result of local innovation. Now, here, demographic and environmental factors could promote cumulative cultural adaptation that result in technological change. Now, as examples of this, I'm highlighting perhaps the potential that we see in some of the youngest Acheulean assemblages, which display a new pattern of invasive flaking onto biface surfaces at the top, as well as the record from the Goa Valley, argued to show a gradual but directional change from middle to late Paleolithic technology in the context of increasing population sizes and deteriorating environmental conditions. Secondly, cultural change could spread as a result of contact between adjacent populations, spreading ideas, resulting in the adoption of new technology. So it's the ideas that are moving rather than people. Now, this has been a more classic argument in Europe and European debates about the appearance of symbolic material culture with Neanderthal populations that have been argued to result from contact with Homo sapiens. But some of this evidence now clearly predates the dispersals of modern humans to Europe, and some examples of this are shown at the top. Now, this is not something that's typically argued for in South Asia, but it does remain plausible, as illustrated here by a model from Sheila Mishra, suggesting that the early expansions of Homo sapiens using Middle Paleolithic technologies unable to expand into South Asia. So you can see here's an expansion. And to her, this is blocked by occupation of the region by an Indian archaic population, but this could provide a context for these populations to meet and perhaps to exchange ideas. Finally, cultural change could come as a result of population change, so when the population moves from one region to the other, taking innovations that first appear somewhere else with them. And often we imagine that these innovations perhaps give this population the ability to outcompete resident hominins. Comparative studies led by Chris Clarkson suggest that South Asian Middle Paleolithic core technologies mark a sharp break from the late Acheulean and share common features with some African Middle Stone Age assemblages, as well as early Australian assemblages, suggesting that they have a shared cultural heritage rooted in shared demography and argued to result from the earliest expansions of Homo sapiens. Now, others have argued the appearance of microlithic technology marks comparable technological replacement relating to demographic overturn. So For me, the evidence for the local innovation of late Paleolithic technologies in South Asia appears compelling, with key technological features often rooted in early and Middle Paleolithic Middle Paleolithic industries. And this is supported by some of the regional variability that we see in the timing and expression of the late Paleolithic. Where we have far less evidence to work on is with the late Acheulean to Middle Paleolithic transition. And as I've highlighted, the recent report from Atarampikan complicates this picture. Before this came to light, I was much happier supporting replacement as a model for the origins of the Middle Paleolithic in South Asia. So I think here it's worthwhile considering some interregional perspectives to try and put this into focus. So I'm going to start off very briefly looking at Eastern Africa. It's a region in which the late Acheulean to Middle Stone Age transition is relatively well understood and nicely typified by this illustration from sites from the Kapfuran Formation, demonstrating that we see a mosaic appearance of key Middle Stone Age technologies, such as the use of Lavawa method. Again, you can see alternate symbols down here for Lavawa methods, as well as hand axes made from Lavawa cores appearing, and critically that they're associated with some of the classic Acheulean tool types frequently as well, such as with cleavers, with hand axes. So we see this the isolated or mosaic appearance of key Middle Stone Age technology, such as Lavawa technology and blade production, nested within the Acheulean, dating between 500 and 300,000 years ago, prior to the abandonment of heavier tools to just focus on these elements of Lavawa, flakes, points, as well as blade technologies after 300,000 years ago. So for me, this might be a textbook case of how we might imagine a local innovation to look like at the late Acheulean to Middle Paleolithic transition. Now, an alternative picture here can be seen at the transition from to the Middle Paleolithic in the Levant. And here I've just shown you a schematic that represents an excellent summary of presentations by Yossi Seidner and Lilian Mignon at the EAAs a couple of years ago. So you can see on the left that we have a later Acheulean associated with refined bifaces and preferential surface cores. Movement into what's called the Acheulean. You see the continuity of these features, albeit with much coarser bifaces, but with the addition of a distinct blade component, as well as keener production systems. And the latter is a form of plate production as well as retouching into tools. And then finally, we see the early Middle Paleolithic. And this is highlighted in every case by the first appearance of Lavawa flakes, points, or blades, and still associated with systematic blade production and retouch points. Now, here, the appearance of Lavawa technology and Middle Paleolithic assemblages are argued to result from a population replacement, with Ronnie Schimmelnitz and colleagues arguing that this wider technological change is associated with the appearance of hafted toolkits. Now, what might be particularly useful in making comparisons to regions such as the Levant is a recognition of a diverse range of core reduction approaches, such as preferential surface cores, shown on the right-hand side here. So while much of our focus on later Acheulean assemblages in South Asia has been on these large bifacial tools, hand axes, and cleavers, I think there's a growing need to examine core technologies in a similar systematic manner if we're going to use the Levant as potentially another comparison for seeing how the later Acheulean to Middle Paleolithic transition would look associated with population replacements. So summing up now and returning to South Asia, in the Middle Sun Valley and Jurero valleys, we see clear evidence for a sharp transition from the late Acheulean at the end of marine isotope stage 6, dating between 140 and 120,000 years ago, and the appearance of Middle Paleolithic in MIS5, both regions about 80,000 years ago. Elsewhere, we see comparable patterns, but without such clear chronological controls, such as in Central and Western South Asia. Now, as it stands, the appearance of the Middle Paleolithic at Atarampicum is also argued to mark a sharp change from preceding Acheulean industries. So how can we explain this pattern and these regional differences? So for me, firstly, in terms of hominin demography, culture and paleoclimates, I can't see any reason why South Asia couldn't have been a centre for technological innovation in the Middle Pleistocene. So that demands that we must examine the factors that promoted innovation amongst South Asian and Acheulean populations as a key step prior to the emergence of perhaps an early Middle Paleolithic. Secondly, and on a related matter, South Asia is large and it's ecologically diverse. So it's plausible that populations in different parts of the subcontinent use significantly different toolkits. So this demands that we question why Acheulean technologies could have persisted so late in some regions, such as the Middle Sun Valley and Jurero Valley, but not others. And similarly, why Middle Paleolithic technologies appeared in some regions, such as Atarampicum, but didn't appear to spread, or only spread at a much later time frame. Finally, if modern humans expanded across the monsoonal threshold using Middle Paleolithic toolkits, it's feasible that they could have encountered another Middle Paleolithic using population in South Asia too. So we need to consider how we might differentiate them from one another. Finally, returning to the Thar Desert, my experience here has shaped what I see as perhaps a critical change that could be a key feature in the Acheulean to Middle Paleolithic transition. So I've been questioning the origins of hafting in South Asia, and this is the result of repeatedly encountering diverse forms of point technologies in the field, including different Labawa methods of producing points and different retouch strategies that include the production of bifacial points, as well as shouldered and tanned pieces. Now, producing hafted tools is more complex than handheld tools alone. They require mastery not just of one material, such as stone, but multiple different materials, as well as the skills to integrate them into one effective tool. In that sense, they're costly and more complicated. But they enable production of a much broader array of tools. They can leverage more force and be used at a distance, which often make them superior to handheld tools. Now, what we presently lack for the Paleolithic in South Asia is clear functional or use-wear work to robustly identify the presence of hafting, which requires substantial investment in experimental work, and instead we have to rely on artifact typologies as indices for hafting. But I think that there are some good reasons that we can start to talk about hafting as an issue, even before we have robustly identified its presence, and particularly its role in examining the transition from the Acheulean to the Middle Paleolithic. Firstly, it's a clear reminder that stone tools are likely part of much richer material worlds, and thinking about the other inorganic and organic elements necessary for hafted technologies, and the landscape learning required to successfully acquire them helps broaden our understanding of the Paleolithic. Secondly, it helps highlight how crossing the monsoonal threshold, so expanding out of the desert belt and into India, may have significantly impacted some of the organic resources available for using hafted tools. So as we see this ecological change, we might see some of the resources needed for hafting, such as resins, changing their distribution, changing some of their chemistries. So that would present very particular adaptive challenges. Now, hafted toolkits can enable higher levels of mobility, and perhaps this was of importance to a population's ability to begin to engage with a new resource base. But the capacity to return to more familiar ecologies, such as stable fluvial landscapes of the Thar Desert, perhaps mean it was an ideal place for expanding Homo sapiens populations to begin to engage with monsoonal habitats in South Asia without completely having left some of the more arid landscapes with which they're familiar. Finally, thinking about hafting requires us perhaps to rethink the nature of the Middle to late Paleolithic transition too. It may well be that it was the development of new hafting approaches that unlock the potential utility of different stone technologies promoted their mosaic appearance in different ecological contexts within South Asia. So perhaps it's the means of hafting rather than the ability to produce microliths that led to that transition. So thank you very much again for the invitation, and thanks to everyone for listening. My work would not be possible without the incredible hospitality I've received on every trip to India. And I thank a whole host of collaborators, particularly Homo and Professor Ajit Prasad, who supported me so much, and a number of the students that I'm working regularly with from Baroda, including Avi Mukherjee, Devar Anil Kumar, and Praveen Kumar. So thank you very much. And I'm looking forward to trying to tackle your questions.